Let's walk through an example of music prediction using a traditional recurrent neural network. First, we build a kind of super song by merging melodies from hundreds of songs into one long sequence of notes. Then, the goal is to prepare a dataset that is needed for training a machine learning model that can predict the next note in a melody given the previous 8. To do this, we slide across this super song, taking 8 note segments as the explanatory variable and the following note as the target. We start creating the first row. Notes 1 to 8 becomes the explanatory variable, and node 9 becomes the target. Then we slide one note forward in the super song. Notes 2 to 9 become the new explanatory variable, and node 10 becomes the target of the second row. We repeat this process sequentially, creating row after row, third, fourth, fifth, until we reach the end of the super song. This gives us thousands of training examples, each one teaching the model to predict the 9th note from the previous 8. As you can see, this is nothing more than a typical machine learning model that aims to understand the pattern that relates the explanatory variables, being now the first 8 notes of a melody fragment, to the targets, being the following one. And here's one of the most exciting things. We will evolve a typical machine learning model developed for predictive purposes into a model that is able to generate new melodies. Let's see how this generative model works. As in every generative model, we need to start with a prompt. Here, the prompt will be a melody of 8 notes. In recurrent neural network theory, this is called a seed. The seed works just like a prompt in a language model. It could be random, composed, or extracted from existing music. Using our newly trained machine learning model, we start with these 8 seed notes from S1 to S8 and predict the 9th note. That 9th note becomes the first generated note, which we'll call GN1. Then we slide forward into the melody composed by the seed and the just generated note GN1, feeding the next group of 8 notes to the model, and the model predicts GN2. This process continues, generating one note at a time, always using the previous 8 notes as input. Eventually, all the notes fed into the model will be generated once, GN1, GN2, GN3, and so on, producing new melodies that stay coherent with everything that came before. And this is how a basic music AI generative model works. As we've seen, it begins as a predictive model trained on the supersong dataset. Then, once seeded, it can generate an unlimited number of new melodies inspired by that training data. This is super exciting because at the end of the day, a generative model in music is nothing more than a predictive model that we prepared to generate new notes and music.